This experiment is on combined loading. We have studied states of stress from various types of loads as they are applied independently on a structure, and those have been done previously. For a state of combined loading, the stress states from these individual loads can be superimposed to determine the combined loading stress state. Through this, we use a strain gauge rosette that you can see here in a 45-degree format. So from this, we're going to get a different set of strains and then incorporate that into finding our principal stresses using Morse circle. So our combined loading setup has a rectangular bar and a hollow cylindrical tube. One of the first steps that we do in this experiment is we want to measure the length of the rectangular bar and also the length of the cylindrical tube. So there's an indentation sort of where that cylindrical section or where those two pieces meet, and we're going to measure it from that point. So we measure from that particular point to the end of the rectangular bar, and this will be used as one of the lengths in our experimental setup. So this one's about 3.95 inches, and then the second length that we will measure will be the length from the strain gauge rosette to that same indentation point where those 2 points meet. So in this particular experiment, we're looking at 2 different length segments, and then we will use those 2 lengths in order to determine how the stresses interact from our strains that we find in the experiment. So we're getting the length of the second segment, so we use the point or the connection point as kind of our end point, and then we're going to measure to the center of our strain gauge rosette. So this is about 5.03 inches in this experiment. So now we have the 2 lengths. So once we have the 2 lengths, what we want to do is get the strains that are attributed to our 0.45 90-degree strain gauge rosette. So the first thing that we're going to do is set up our strain indicator to be ready from our initial test state. So the first thing that we're going to do is check the channels. So we want the gauge factor to be 2.02. So we verify that the gauge factor is set to 2.02 in each setup, and we want the bridge type in this experiment to be a quarter bridge type because we're looking at a tension type experiment, or we're loading our particular setup in a tension fashion, so just a singular load pressure section. So we have our P plus S minus and our D120 as our setup, where the D is our resistance value. So once we know that our quarter bridge setup is indicated for each of our channels, we can balance our test system. So it'll say it can't balance channel 4, and that's because we don't have any wires plugged into our channel 4 setup in order for that gauge to be identified. So now we see that we have all of our strain indicator values set to 0. So we have 0 as our our strain state is set to 0. So the first thing that we're doing is we're adding 0 to 10 pounds in 2-pound increments. So we want to get the 0, 45, and 90-degree segments at 2 pounds, 4 pounds, 6 pounds, 8 pounds, and 10 pounds. So this is our 2-pound setup. So we have -8, 120, and 87 microstrain, which are the units in this case that we're using. All of our values are in microstrain. So now we want to put 4 pounds on, and we'll get the values at 4 pounds. So what we're essentially doing in this segment is making sure our values are being incremented in a linear fashion, and that'll be what we use for our graphical setup in order to show that our values are fairly linear, and then once they're linear we can do our test setup, or not necessarily test setup, but our calculations at that 10-pound load, knowing that the values leading up to that point are valid. So now we're putting 6 pounds on, and we'll get the values for a 6-pound load. So for the 6-pound load, we have about -24, 361, and 259. And then we'll do our 8-pound setup. So we see our values for our strain indicator for our 8-pound setup. And then we'll do a 10-pound setup, which is, this is the value we'll do our calculations at. And again, all of the values that we're recording are in microstrain, so when we do these calculations, these values would be whatever value you see times 10 to the minus 6th. So our test setup is aluminum, so it's a 6061 T6 aluminum setup, so our modulus of elasticity for this would be about 10 million psi, and here you see the values for our 10-pound setup. So it's about -45, 607, 609, and 437. So we'll use those values to calculate our principal stress in two directions, so our principal stress 1 and principal stress 2, and we'll formulate those with a theoretical setup using a free body diagram as our theoretical setup using those two links that we found at the beginning. And then this is our last measurement, which is double checking our zero value once the test is completed. So then now the test has been performed and our experiment is complete.